Why force is the foundation of physics. Force is one of the most fundamental concepts in physics. Every movement we observe around us, every object that stops, starts, changes direction, or changes shape does so because of force. From walking and running to flying airplanes, from opening a door to the motion of planets, force is involved everywhere. Without force, the universe would be static, lifeless, and motionless. In everyday life, we use force without even realizing it. When we push a chair, pull a bag, kick a ball, or lift a book, we are applying force. Understanding force helps us understand how and why objects behave the way they do. This is why force forms the backbone of mechanics and classical physics. What is force? In the simplest terms, force is a push or a pull. Whenever two objects interact with each other, they apply force on one another. This interaction may occur through direct contact or even without physical contact. A force can make an object move, stop a moving object, change its speed, change its direction, or even change its shape. Force itself may not be visible, but its effects are clearly observable. Scientific definition of force in physics: force is defined as a force is an external agent that can change the state of rest or motion of an object, or can change its shape. This definition clearly shows that force does not always cause motion. Even stopping an object or deforming it is an effective force. Force as a vector quantity: force is a vector quantity, which means it has both magnitude and direction. The effect of a force depends not only on how strong the force is, but also on the direction in which it is applied. For example, pushing a box forward and pushing it sideways produce different results. Two forces of equal magnitude can have completely different effects if their directions are different. Effects of force on objects: force produces several important effects on objects. Understanding these effects helps us analyze physical situations clearly. Change in state of rest or motion: one of the most important effects of force is changing the state of motion of an object. An object at rest does not start moving on its own. It requires force. Similarly, a moving object does not stop automatically unless a force acts on it. For example, a football lying on the ground remains at rest until someone kicks it. A moving bicycle slows down when brakes are applied because braking force acts opposite to motion. Change in speed of an object: force can increase or decrease the speed of an object. When force acts in the direction of motion, speed increases. When force acts opposite to motion, speed decreases. For example, pressing the accelerator increases the speed of a car, while pressing the brake decreases it. Change in direction of motion: force can change the direction of motion without changing speed. This is clearly seen in circular motion. For example, when a stone tied to a string is rotated in a circle, the direction keeps changing due to the force applied by the string. Similarly, a cricket ball changes direction when hit by a bat. Change in shape or size: force can also deform objects. This deformation may be temporary or permanent depending on the material. Stretching a rubber band, compressing a spring, squeezing a sponge, or bending a metal rod are all examples where force changes shape. Balanced and unbalanced forces: forces acting on an object may be balanced or unbalanced. Balanced forces are forces that are equal in magnitude and opposite in direction. When balanced forces act on an object, there is no change in its state of motion. For example, a book resting on a table experiences gravitational force downward and normal force upward. These forces balance each other, so the book remains at rest. Unbalanced forces are forces that are not equal or not opposite. These forces cause a change in motion or shape. For example, when you push a box and it starts moving, the applied force becomes greater than friction, resulting in motion. Classification of forces: forces are broadly classified into contact forces and non-contact forces, based on whether physical contact is required. Contact forces act only when objects are in physical contact with each other. Muscular force is the force exerted by the muscles of humans and animals. Most daily activities such as walking, lifting objects, pushing doors, and pulling ropes involve muscular force. Though muscular force is limited, it is extremely important in everyday life. Frictional force. Friction is a force that opposes the relative motion between two surfaces in contact. It always acts opposite to the direction of motion. Friction helps us walk without slipping, write with a pen, and stop vehicles using brakes. However, friction also causes wear and tear and energy loss in machines. Normal force is the force exerted by a surface on an object resting on it. It acts perpendicular to the surface and balances the weight of the object. Without normal force, objects would pass through surfaces. Tension is the force transmitted through a stretched string, rope, cable, or wire. It acts along the length of the string. Examples include pulling a bucket from a well or lifting objects using ropes. Non-contact forces act even when objects are not in physical contact. Gravitational force is the force of attraction between any two masses. Every object in the universe attracts every other object. The gravitational force of the Earth pulls objects toward its center, causing them to fall. This force also governs the motion of planets, moons, and satellites. Magnetic force is exerted by magnets on magnetic materials like iron, cobalt, and nickel. Magnets can attract or repel each other without touching. Magnetic force is used in electric motors, generators, speakers, and many modern devices. Electrostatic force is the force between charged objects. Like charges repel, while unlike charges attract. Examples include a charged comb attracting small paper pieces and lightning during thunderstorms. Force and Newton's laws of motion. The concept of force is best explained by Newton's 3 laws of motion, which form the foundation of classical mechanics. Newton's first law of motion. Law of inertia. Newton's first law states that an object remains at rest or in uniform motion unless acted upon by an external unbalanced force. This law introduces the concept of inertia, which is the resistance of an object to change its state of motion. For example, passengers move forward when a moving bus stops suddenly due to inertia. Inertia and mass. Inertia depends on mass. Heavier objects have more inertia and resist change more strongly than lighter objects. This is why it is harder to push a loaded truck than an empty one. Newton's second law of motion. Newton's second law provides the mathematical definition of force. It states that the rate of change of momentum of an object is directly proportional to the applied force and occurs in the direction of force. Mathematically, this law is written as F equals ma. This equation shows that force depends on mass and acceleration. Newton's third law of motion. Newton's third law states that for every action, there is an equal and opposite reaction. Forces always occur in pairs. When you walk, your foot pushes the ground backward, and the ground pushes you forward. This law explains walking, swimming, jumping, and rocket propulsion. SI unit of force. The SI unit of force is the Newton, N. 1 Newton is defined as the force required to accelerate a mass of 1 kilogram by 1 meter per second squared. Measurement of force can be measured using devices such as spring balances and force sensors, which work based on deformation caused by force. Force, momentum, and impulse. Momentum is defined as the product of mass and velocity. Force changes momentum. Impulse is defined as the product of force and time. Increasing the time of impact reduces the force experienced. This explains why airbags and seat belts reduce injuries. Applications of force in daily life. Force plays a crucial role in transportation, sports, construction, medical science, engineering, and space technology. Machines are designed based on the principles of force to reduce human effort. Advantages and disadvantages of force. Force allows motion, work, and control over objects. However, Excessive or uncontrolled force can cause damage, accidents, and wear and tear. Importance of studying force. Understanding force helps us design safer vehicles, stronger buildings, efficient machines, and advanced technology. It is the foundation for studying work, energy, power, pressure, and motion. Conclusion: force is the key concept that explains how objects interact with one another. From the smallest particle to the largest galaxy, force governs motion and stability. Mastering the concept of force opens the door to understanding the physical world deeply and logically. Call to action: if this force lecture helped you understand the concept clearly, backhand index pointing right, like the video backhand index pointing right, share it with your friends backhand index pointing right, subscribe to the channel for more detailed physics lectures, comment below which topic you want next. Work, energy, power, gravitation, pressure, or laws of motion. Numericals. Keep learning, keep questioning, and stay curious. Rocket Blue Book.